Today in Capechi's Corner, we're going to talk about arcs and central angles. As we explore arcs and central angles, we need to look at some vocabulary words. The first one is a central angle. That's an angle with its vertex at the center of the circle. So if O is the center of my circle, the central angle, for example, could be something right there. When we're talking about an arc, we're talking about an unbroken part of a circle. We're not starting and stopping, it's continuous. So we have an arc here, we have an arc here, and we also have an arc around here, and we'll talk about the names of these specific arcs. When we're talking about adjacent arcs, we're talking about arcs that have exactly one point in common and they do not overlap. So I could say the word adjacent we know means next to. That's basically what adjacent arcs are. They are arcs next to each other. So if we say this point A is the one point they have in common, we can say this arc right here is adjacent to this arc right here because that point A is next to each other and they do not overlap. So we can say that arc AC and arc AB are adjacent arcs, and we're going to talk about how we actually write arcs in just a minute. Now we're going to talk about specific types of arcs and how to name them. A minor arc is an arc measuring less than half the circle, and we use two letters to name it. So for instance, this arc right here, AB, and we write that as AB, and we put an arc on top of it. That's our symbol. Another minor arc would be, for instance, arc BD. We could also call that DB, doesn't matter. We have another arc in there that's a minor arc AC. And again, we can call that arc CA. The order doesn't matter. Other minor arcs we have arc CD. And our last minor arc we have in this diagram is we have arc AD. Now let's look at the major arc, which is an arc measuring more than half the circle, and we use three letters to name. So this arc right here, I could call CAD, so I could call arc CAD. I could also call that same arc CBD. Now the reason we use three letters, it kind of tells us the direction. If I were to just say CD, then I would think I was going here in this direction, but I wanted to go kind of all the way around. I want to do a major arc, which is why we use three letters. Another major arc is arc ADC. So again, that's going to go all the way around there. So I'm going to say arc ADC. Another way I could say that is ABC. I could also say BCA. So BCA is there. So again, there's some examples of major arcs. Now I think it's somewhat easy to remember major versus minor. We do a lot in baseball. We talk about the major league and the minor leagues. So that's kind of the easiest way to remember which is which. Now the last type of arc we're going to talk about is a semicircle. And the semicircle measures exactly 180 degrees. So it's half the circle because we know that the circle has a total measurement of 360. So there's two semicircles here. I can say CAB. So CAB, again, we use three letters so I know what direction I'm talking about. And I can talk about CDB. So again, they are my semicircles. Now we have a postulate. It's called the Arc Addition Postulate, and it's the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs, which kind of makes sense. We're going to add them together. So the measures of the minor arc is the measure of the central angle. That's something else that's important to know. So for instance, in number 1, we have the measure of arc AB, which is right here. That's a minor arc. And because our central angle is 60, we know that's 60. In number 2, we're looking for the measure of arc CAB, which is here. That's a semicircle, so that's 180 degrees. And I'm looking for the arc in number 3, the measurement for CDB, which is this way, so that's also 180 degrees. Notice there's two different ways to list them because it's telling me the direction that I want to go in discussing which semicircle. Number 4 is looking for the measure of angle AOC. Well, a lot to do with circles is the semicircles because we know that's 180. So if I know that this measurement right here is 60 and I know that I have a semicircle, then I know this measurement right here has to be 120. So the measure of angle AOC has to be 120 because it forms 180, which is a straight angle, which is a semicircle. And number 5, the measure of arc ACB, so I'm going all the way around. And I know this piece right here is 120 plus the semicircle is 180, so I know the measurement of that arc is going to be 300. Number 6 is asking for the measure of angle BOC, and that's a semicircle, so that's 180. And in number 7, we're looking for the measure of arc ABC, so we're going all the way around here. So I know that that's going to be 60 plus 180, so that's going to give me a measurement for that arc of 240. Just a few things to remember. Notice in all of these problems, whether I was asking for the measure of an arc or the measure of the angle, I was using the M symbol. So again, arcs work a lot like angles. When I'm just naming the arc, I don't need the M symbol, but if I'm giving it an actual measurement, then I do, similar to how we do with angles. The other thing is, all of these measurements we're able to figure out what they are because of the fact that there's a central angle. They are a part of that center, which is O. So for instance, in angle AOB, we know is 60, so therefore we're able to figure out what these arcs are on the outside because of the central angle. For our last problems for today, we're going to find the measure of central angle 1. So in an example 1, it lines up pretty well. We know the arc is 72, so I know that the measure of central angle is 72. In number 2, again, I'm looking for the measurement of angle 1, which I don't have. I have 130 right here, but again, I notice that I have a semicircle right here, so I know that's going to be 180. So I'm going to take 180 minus 130, and I know the measure of that angle 1 is going to be 50.